So the next shape we have for this related rates is expanding/shrinking a cube. The volume of a cube decreases at a rate of 0.5 cubic centimeters per second. So we're going to talk about volume. And we want to figure out what is the rate of change in the side lengths when they are 12 centimeters long. So we have volume and we have side lengths. Well, in general, volume is length times width times height. But we're talking about a cube. So a cube indicates that we have all square sides, everything's the same, the length is the same as the width, is the same as the height. So instead of choosing L, W, or H, I'm just going to call it sides. So you have the first side times the second side times the third side, and so you're multiplying it by itself 3 times. So you get S cubed. So our equation that relates our two variables is going to be that the volume is whatever the side lengths are cubed. Okay? So now before we take the derivative of this, which we're going to end up doing, I'm going to think about my variables that I have. So I have V and I have S, and then I'm going to think about their derivatives. dV dt has the volume changing with respect to time. Do I know that, or am I finding that? And how is the side length changing with respect to time? Do I know that, or is that what I'm trying to find? So we have the volume of a cube decreases at a rate of 0.5 centimeters cubed per second. So we're talking about volume. So we're either talking about V or dV dt. V would just be a number, dV dt would be a rate. So this says the volume of a cube decreases at a rate of 0.5 centimeters cubed per second. So we could tell by either the two units that it's a rate of change, or the fact that it says decreases or rate. There's lots of hints here saying that this must be dV dt, not just V. It's 0.5 centimeters cubed per second, and it's decreasing. So what kind of derivative should it be? It should be negative. So dV dt is negative 0.5 centimeters cubed per second. The other number we're given here is what rate of change are the side lengths. So we're trying to find ds dt. We're always solving for a derivative when they are 12 centimeters long. So S must be 12 centimeters. So what we're trying to find ds dt, I'll enter the units on it. So S is in centimeters. That's the sides. With respect to time is seconds for this one. So I'm missing the, I'm not even going to plug in and find it. If I need it, I will plug in where? The original or the derivative? We always plug into the original. If we need this, we will plug into the original, which is V equals, and we would do 12 centimeters cubed. If we need it, we'll go back and find it. Most of the time, you don't. Sometimes you do, and then we'd go back and find it. So now that we have our equation and our variables and their derivatives, we are ready to take the derivative and plug in for what we know and solve for what we don't. So the derivative of 1v with respect to time is just going to be 1 dv dt. And then the derivative of s cubed with respect to time would be 3s squared ds dt. Okay. So now that we have our derivative, we're going to plug in all the pieces that we know and solve for ds dt. We always know one rate and we're solving for the other. So I know dV dt. The volume is decreasing by 0.5 centimeters cubed. So I'm going to just plug in a negative 0.5 on that side. And then we're going to write equals 3 times my s, my current side length is 12. And that's getting squared. And then I'm solving for ds dt. So the important thing with plugging in here is that we need to do PEMDAS. So we're going to square before we multiply. So we're not going to do 3 times 12 and then square it. We're going to do 12 squared first and multiply that by 3. So we have negative 0.5 equals 3 times 144. Doing that squaring first. So grab your calculator and see what you get. So now we do 3 times that 144. We just plug that in. We have negative 0.5 equals 432 ds dt. And then to get ds dt, we divide by 432 on both sides. So that negative 0.5 over 432, when you plug that in, you get 0.0011. It's a really tiny number. You can hit math, enter, and it'll change it back to a fraction, or you can leave it as a decimal and round if that's what WebAssign wants. I'm going to put it as a fraction. It's negative 1 over 864. There is my ds dt. So the last thing I would need to do is just put some units on this and interpret. So my units with ds dt are centimeters per second. So we would say, first we talk about the derivative we know. So as the volume decreases by 0.5, remember you don't say a negative 0.5, decreases by 0.5 centimeters cubed per second. Very small decrease in the volume. So as the volume decreases by 0.5 centimeters cubed per second, the side lengths do what? Do they increase or do they decrease? Well, a negative means decrease. Decrease, and you can make this a decimal if you want to, maybe all around just for this interpretation, decrease by 0.001 centimeters per second, which makes sense. So when the volume to decrease, the side lengths have to decrease, and their volume's only decreasing by 0.5 centimeters cubed, so the side length is only going to decrease by 0.001 in order to make that happen.